Hi, my name is Justin Pitts. I'm a first year PhD student in the IE department. I work in the Roland and Zare labs in the agronomy and ECE departments, respectively. A main facet of my dissertation focuses on primed acclimation across various crops. And today I'll be talking about the impacts of primed acclimation in Arabica coffee. So, coffee is a crop that many of us are familiar with from everyday use and represents a massive market globally. An industry centered on the growth, production, and sale of coffee has an estimated worth of well over $100 billion and supports the livelihoods of countless people worldwide. The coffee we all know and love, however, may be at risk if current climate trends continue. Coffee thrives under a narrow range of temperature and precipitation, while having relatively strict requirements for timing and quantity of annual rainfall. Future climate projections show that the occurrence of drought events, as well as drought intensity, are forecasted to increase in many coffee growing regions throughout the world. Drought can wreak havoc on coffee, resulting in smaller beans of uneven size and lighter density. Beans of varying size grades are bad for specialty coffee roasters who need more uniformity to get an even roast. Smaller beans are usually not accepted as export quality for this reason, and farmers are forced to then sell them at a lower price on the local market. The result is less exportable coffee volume and less income in the pockets of farmers of coffee. In hopes of combating future impacts of drought, one aspect of my research is to determine the influence that a novel irrigation approach, called primed acclimation, has on water use, physiology, root infrastructure, yield, and quality in Arabica coffee. Primed acclimation is an irrigation regime which exposes plants to mild drought stress via reduced irrigation. The idea behind primed acclimation is to maximize short-term water use efficiency by eliciting changes in physiological functioning and or genetics to better prepare, or prime if you will, these plants for future drought stress. In its most elementary form, primed acclimation can be considered analogous to a drought vaccine, as it introduces a mild stress event in the form of reduced irrigation to the plant in hopes of eliciting a stress memory to help combat future drought. Using primed acclimation has been shown to improve water use efficiency at little to no cost to yields in numerous fruiting plants. However, it is severely understudied in coffee, leaving a large knowledge gap for such a globally important crop. If promising in coffee, primed acclimation could lead to more drought-resilient plants in the face of future climate change and reduced irrigation costs for growers globally. So to better understand the effects that primed acclimation has on coffee, I will examine the physiological and morphological impact on 40 mature Arabica coffee clones, which are greenhouse grown here at UF's Plant Science Research and Education Unit in Citra, Florida. For my study, plants will be evenly split into 4 experimental groups, receiving 0, 1, 2, or 3 drought treatments. A drought treatment entails implementing a 2-week period where irrigation will be completely withheld. Following each drought treatment, plants will be rehydrated until stem water potential, high levels of which are indicative of water stress in plants, return to the same levels as plants not receiving drought treatments, in other words, the control plants. Once water potentials are back to acceptable levels, the next round of drought will begin for plants undergoing additional drought treatments. Throughout my study, impacts of primed acclimation on physiology, root architecture, yield, and quality will be assessed. During each drought treatment and rehydration period, biweekly measurements of leaf gas exchange, weekly measurements of stem water potential, and leaf relative water content will be measured across all trees. Gas exchange will allow me to measure rates of CO2 assimilation, which is directly related to productivity, as well as rates of transpiration and stomatal conductance, which reduced levels of have been linked to drought stress in coffee. Stem water potential and relative water content will provide measures of drought stress, with high values of stem water potential and low values of relative water content being indicative of drought stress in most plants. In addition to leaf level physiology, root level impacts will also be observed through weekly mini rhizotron imagery across all trees. Root imagery will allow me to assess changes in rooting depth and length across each priming treatment, both which can improve drought resilient in many crops. Additionally, a subset of trees will be fitted with sap flow collars. These collars will allow me to examine whole tree water usage throughout the entirety of the experiment and hopefully isolate the onset of any physiological changes associated with priming. Finally, yield and quality will be analyzed across all fruiting plants. So based on the results from other crops and previous studies, I expect plants undergoing primed acclimation to differ from control plants by having reduced transpiration and stomatal conductance, while I expect rates of CO2 assimilation to remain relatively unchanged, decreased rates of sap flow, increased rates of stem water potential, maintained or increased relative water content, increased root rooting depth and mass, especially in trees receiving 3 drought treatments, and the potential for fruiting to be disrupted, resulting in decreased yields, but potentially improvements in quality. That completes the entirety of my 5-minute speech, and I'll be around for additional questions at the live session if you have any. Thanks again.